Hi, my name is Sergio Cruzes. Today I'm going to talk about disaggregation in optical networks. Disaggregation in optical networks we're seeing as a dream for years. Now this is turned into reality. You can see a lot of lab trials, we can see proof of concepts, we can see a lot of events about this. But what is disaggregation? In simple words, disaggregation is the move from the traditional closed systems towards an open environment where you can mix different vendors. There are two types of disaggregations. A fully disaggregation system and a partially disaggregation system. A fully disaggregation system is a system where you can mix different building blocks from different vendors. You can mix amplifiers, ROADMs, WSSs, MUX, demuxes, all this together in your network. So the operator builds its network based on these models. A partially disaggregation system is a system where the optical line system comes from one vendor and the optical transponders come in pairs from another vendor or other vendors or a bunch of vendors. In this case, you don't need to have ROADM interoperability, neither transponder interoperability. But disaggregation, there is a cost for disaggregation. This cost refers to integration among the integration that refers the integration among these different models and also the integration with the management system. The core of your disaggregation system is the open SDN controller. The SDN controller is responsible to manage and control your networks, responsible to provide the state awareness of your networks, responsible to provisioning a light path in your network, responsible to provide restoration in case of failure of these connections, is responsible to assign frequencies for these connections, responsible to provide a report about the spectrum oscillation in your networks, responsible to provide its capability to the upper layers that have tools regarding machine learnings, data analysis, data planning, system planning. So a lot of information to the upper layers, and this is done through the RESTful APIs, Application Programs Interface. And also to support this wide variety of devices, strong abstractions are necessary in your network to avoid the vendor lock-in. And the Young data model provides consistent abstractions of the network elements. OpenConfig and OpenRandom are two initiatives that leverage these Young data models, and the Young data models together with the netconf protocol. Netconf protocol is called the SDN protocol. So Young and netconf are considered the preferred one for interacting with the control and management systems of your network. As a result, Young and netconf offer a common method for management and control network components or devices apart from the vendor. I wrote a paper about disaggregation in optical networks, and this paper provides the best practice for designing, planning, and operating disaggregated optical networks. I also present the interactions between the models, such as the OpenSDN controller based on ONOS, the optical line controller, the orchestration module, and also the QT estimator module that is based on GNPI, the Gaussian Noise Simulation Python, that is responsible to provide estimations of impairments in your network and provides information about signal to noise ratio in the network, and to provide what modulation type can be performed in your network. So details about this paper you can find in the internet, and I will provide below the address for you to download the paper. Thank you very much. See you soon.